Hello guys and welcome back to my YouTube channel. Today we'll be talking about discovering and defining limits. Once again, my name is Eric Fabian Cardenas and I am a senior at Lopez Early College High School in Brownsville, Texas. And this is a YouTube channel mainly focused on AP Calculus AB. So, discovering and defining limits, right? If we look at this first example, we can say that, so use the following graph to evaluate each problem. Okay. So number 28, limit. So you will read this equation right here as x approaches -2, what is the limit of f of x? So what this means in essence, right, is that when x approaches -2, so when x is approaching this way and when x is approaching this way, what is -2? So we can see that whenever x approaches -2, f of x approaches 1, right? It's going towards this 1 right here. Okay, hopefully that makes sense. Let's continue. Limit as x approaches 1, what is the limit of f of x? So what as x approaches 1? So we go down here. So x approaches 1, boom, from both sides. We can see that f of x approaches -2. Put that there. As x approaches 2, f of x, so if I can erase these lines, f of x, so as x approaches 2, f of x approaches -1, right? And then here's a little more simple, right? What is f of -2? Well, f of -2, we come back over here. Let me get some of this out of the way. F of -2 is simply 3, right? Right up here. -2 and 3. So then we ask, okay, well, what is f of 1? We go to we find f of 1 right here. Come down. That's that. It's a whole. Right, so this simply does not exist. D and E. Next question. As x approaches 0, the limit of f of x is -3. Right, because, sorry. As x approaches 0, here and here, it approaches -3. As x approaches -4, f of x, so coming up here and come down here, what is this point here? -3. And f of 2, find f of 2. This first one is a whole, but further down, that's your f of 2, -3. So hopefully some of this made sense for you guys. And this is just basic limitations when you're talking about graphs and stuff like that in for calculus. Let's look at some more examples. So this example is pretty much just asking us how we would express this equation. So it is that it states that you read this as x approaches 4, f of x approaches 8, -8, sorry. And that's the way you would express that, verbally. All right, let's continue going. So here's something a little different. Right, so here we start getting into finding limitations using different types of graphs. Right, so if you look at this first question here, it says that the limitation of f of x as x approaches -1. But then there's this weird little negative sign on top, right? If you look at question A. So that means that the limitation, instead of it coming from both directions, right, from the left and the right, instead now it'll only be coming from, well, in this case, from the left because it's negative, right? So if we look at x is equal to -1, right, and we come from the left, we see that, right, we're coming up here just from the left, we see that the limitation is 3. So that's our answer for that. Okay, come on. Question B. F of 1. What is f of 1? We come down here to 1, move it up, boom, right there. That's because this is a hole. Down here, that's a hole. So we don't count that. But up here, the dot, so f of 1 is 1. F of x as x approaches 0. Now here, there's no, if we see here, it's just x approaches 0. There is no symbol or anything, right? So then it's from both sides. So from the top and the bottom, as x approaches 0, f of x approaches 0 as well. So that's convenient. Question D. As x, what is the limit of f of x as x approaches 2? But there's a weird little plus sign, right? Okay. So let's look at this. Oh, I'm sorry. This is 0. Limit of f of x as x approaches 2, a little plus up here. So we want to focus on this plus right here, right? Okay. So this means that it's coming in from the right. Whereas on this side, the negative meant that it was coming in from the left. Okay? So if we look at f of 2 coming in from the right, it means coming in this way. Right? So that means that the answer is 1. Right? Because coming in from the right is this point right here, that hole right there. That's what we're looking for. F of -1 right there is 1. F of 2. Okay. We look at f of 2, and f of 2 come up here is a hole, so it simply does not exist. Okay, letter G. Letter G. Limitation of x as x approaches -1 positively. So -1 positively, we're from here to here. So if we come up this way, -1, what is the value of 1 of f of x? I'm sorry, is 1. And then letter H. Letter H. What is the limitation of f of x as x approaches 1 positively? So now we're coming down this way. So we can see that is -1. And then letter I. What is the limit of f of x as x approaches 2? So this is a normal one, so we're coming in from both ways, right? However, we can come in from the positive direction, but it ends there. We can't come in from the left direction, right? There's nothing in this area here that has an arrow placed that way, and so does not exist. Okay. Okay, so looking at this example, we need to sketch the graph of a function g that satisfies all the following conditions. Okay, so what g of 1 needs to equal to 3. So we know that. So we find g of 1, x is 1, y is 3. We know that that needs to be a point right there. Okay, check. The limitation of g of x is equal to -2 as x approaches 1. So x is approaching 1, and then g of x, y, needs to be -2. So we'll leave it as a whole for now. Okay, check. The limit of g of x is equal to 5 as x approaches -3 positively. Okay, so -3 and 5. This is a hole here, and somehow it's going to come down in positively from the y, right? So this is going to come in down here somewhere positively. Check. G is increasing only on -5, only while x is greater than -5 but less than 3, and while x is greater than 1. Okay, so that means that, let's say from this point at -5 to -3, it's positive. And this point from -5 onward is decreasing. So that'll make sense. And x is greater than 1. Okay, so this point from x is 1 it's moving positively, right? And then we have that the limitation of g of x as x approaches -3 negatively needs to be greater than the limitation of g of x as x approaches -3 positively. Okay, so we know that this means is this. So this is 5. So what's a number greater than 5 here? We can just use 6. Okay. So that means that we can't even change things around here. So what we can do is we can probably connect these lines, right? Make that 1 value. But over here, all of a sudden, we need a point up here. And it needs to be a limitation, right? It needs to be a part of a graph. So this part at D that we created, right? Instead of it connecting to the 5, we can just connect it from -5 to 6 and this onward. And now it solidifies and correlates to all the restrictions that they gave us, all the conditions. Well guys, I hope this video was helpful and thank you for watching.